Hello everyone.
There it goes.
This is a midterm exam review. I have I have several students here, a student from another class I have. Here I have in my possession the midterm exam. They will not see it, trust me. However, this review is going to be good because this will be a good review because I actually am going to give you some hints on the midterm exam. Okay, now, I would know what speed is. Speed, velocity, free fall, you know, the old coin in the feather, the rocket problems, ball is thrown straight up. That's the first sentence of a problem. Again, when something falls to the ground, it accelerates, blah, 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 free fall, free fall, free fall. Suppose a jumper claims a hang time of 2 seconds. That's another problem. Cannonball is launched 30 degrees with the horizontal. So we got projectile motion problems. You know what I'll do? I'll do a quick projectile motion problem. Is that good? Yes. So I'll do a type 2 and a type 1. Are we there? Yep. All right, excellent. Okay, now. So a type 2 first. Okay, we'll do the type 2 up here and we'll do the type 1 down here. Okay? Okay? Okay. Okay? Okay. So, type 2. Why I'm doing type 2 before type 1, I was always told as a little kid that I can't count correctly. I received a detention in first grade because I didn't make my 7s correctly. It's a true story. My first detention. Okay, now. So let's say we have a projectile. Okay? Let's say that projectile is shot. Let's say that projectile is shot at an angle of let's say 60 degrees. And let's say that's 100 meters per second. And let's say it's 60 degrees. Okay? If I shoot a projectile at 60 degrees and it has a certain dx, correct? Certain distance. What dx, what angle will result in the exact same dx given the same velocity? Think about that. Maybe somebody want to look that up. Okay? It's a great question. Okay, now, so it's going to go like this. Okay? What we've got to do is we've got to determine, this is really all we need. But we're going to do a lot of things on the way there. Okay? I'll use the bottom of it to do the calculations. So we need things like V naught, which is given. We need angle. We need Vx, Vy. What else do we need, guys? We need Ty. Okay. We need Tx. We need dx and dy. Is that it? Yeah. And is that it? Yeah. Okay, now. So V naught is going to be 100 meters per second, correct? The angle is going to be 60 degrees. Now, Tom is yawning. He looked like a giant hippopotamus. His mouth went like this. Giant yawn. I'm going to call you Hippo Man, okay?
That's a compliment.
It's actually a compliment. Hippos are enormously popular beasts in Africa. Very well known. Excellent. Well, are you back? Yeah. Okay, Justin's back. Okay. So this is going to be, just remember, it's going to be V naught cosine theta, V naught sine theta, correct? Yeah. For V, X, and Vy, right? So V naught cosine theta is going to be Vx, and what's that going to be? 50. And what's this going to be? 86.6 meters per second. So far, so good? What's Ty going to be, Matthew? Quickly, quickly. That's it. Out of the pool. Yes, he's stalling. He's stalling.
I'm sorry, I have to think.
Don't think. No thinking. No thinking allowed.
I need a calculator.
No calculator allowed. Hey, I know, the AP kids, I don't know, falling short here. Oh, now come the excuses, okay.
166.
Gosh.
dy, 2by equals 2y.
dy equals 2y, alright, so.
It's by over d. I'm sitting.
Oh,
I don't think I learned.
Look at your formula.
so it's 8.66.
Yeah, 8.66. We'll say 8.7. Is that okay?
Yeah.
All right? Yeah. Keep it down to 2 centimeter figures. Don't go too crazy with this. So 8.7 seconds. Is that good? Now, Matthew, I'll give you a chance to redeem yourself, Matthew. What is TX?
TX.
Oh my God. He says, you see, when they repeat the question, they're stalling.
I know it.
He needs a calculator.
17.2.
17.2. Thanks for playing. Okay. 8.7 times 2 is 17.2.
17.4.
And you needed your calculator?
Yes.
Let me tell you something. Ladies and gentlemen of the jury, you decide. You only need 4 things to know when you graduate high school, and none of them have anything to do with physics. You have to be able to write really well. You have to be able to read really well. You have to be able to speak in public, and you have to be able to do mental math. If you can't do one of those 4 things, you lost. You missed the point. Okay? Mental math. So 8.7 times 2, 8 and 8 is 16. 7 and 7 is 14. 0.7 would be 1.4. 1.4 plus 16, 17.4. Are we there? 17.4 seconds. Okay? All right, good. Now, you need to plug this in for me, okay? We know that dx, this is my scrap paper up here, okay? That dx equals vx tx. We know that's true, right? So what is 17.4 times vx?
875.
875. Justin just came here and he's already on fire. I love it.
Oh, yeah.
So what did you say it was?
875.
875 meters. Is that correct?
Yes.
870.
870. All right, so let's do it again. So 17.4 times 50.
Yes. 870.
Why'd you say 75?
I put 17.5 instead of 17.4.
That's fine. I understood. That's not too bad. Okay. So this is going to be what's 80? What is this going to be? 87.
870.
870. Okay, good. Now, what is dy going to be? How the hell? What do you do dy? How do you do this? Let's use our scrap paper up here. Okay. Remember what dy is, right? dy is this, right? dy. Now this is the shortcut, Matthew. This is how I teach my students. You ready? Instead of doing all of this mumbo jumbo with, the long equation for dy, I just say, well, that's going to be that vy is going to be 0 right there, right?
Yeah.
So let's pretend we're going to drop a penny from there, and we want to measure the distance that's going to fall. So from rest, ready? I can do this. Vertical distance dy from rest equals the short form of the equation dy equals 5t squared. You got it? You got it? Okay, so dy equals 5t squared. Correct?
Yeah.
Yes?
TY squared.
Ty squared. Thank you. Nice assist. Excellent. 2 points for the EMT. Excellent. So what do we got? So we have 5 times 8.7 squared. What do we got, ladies and gentlemen?
378.
What is it?
378.45.
378. Is that good enough?
Yeah.
Guys, do we have a verification? We need a verification on that?
Yeah.
Verified? Okay, excellent. So that's going to be type 2. Fair? Pretty cool? All right? So we did that, okay? Now, I'll erase this down here. And what we'll do is we'll put up a type 1 problem, all right? So type 1 looks like this. All right? So I'm going to shoot something That look level? Is that good? Does that look level, guys?
Yeah.
All right, so it's going to look like this. Okay? So this is going to be dx. This is going to be dy. And this over here is going to be vx. Okay? Now, this is a little bit of a nice review. In other words, if I have a rifle and I shoot it completely horizontally, right? Completely horizontally, and I have somebody stand right next to me, as soon as I shoot, or I do something with the trigger, where as soon as I shoot, I drop a little metal ball. As soon as I fire, boom! When that metal ball hits the ground, the bullet will hit the ground. That's one of 5 things, or maybe let's say 10 things in science. The mole, clothesline problems. That is one of those 10 things that I never get over I'm 57. I've been doing this since I was 24, 23, 24, and I just never have gotten over the fact that that's true. It's amazing to me. All right, amazing. All right, so let's see. Let's say, by the way, this is dy, right? All right, that's dy. Yeah, easy. All right, that's dx. So let's say that vx. We're going to say vx is called the what? It's called the muzzle velocity. That's going to be equal to 500 meters per second, which is no joke. Okay, what's 500 times 3,600 divided by 1,600? 1125. So that's 1125 meters per. Miles per hour. That's like a serious rifle. Yeah. Yeah. Okay. So then we're going to say the dy, the height of the mountain, the height of the hill, is going to be dy is going to be 1,000 meters. That's dy. Okay? It's going to be 1,000 meters. So this is 1,000 meters. Okay? I don't know if that's going to come out. Okay? 1,000 meters. Okay? That's 1,000 meters. The muzzle velocity is what? 500 meters per second. All right, so how long is that going to stay in the air? How long is that going to stay in the air? So it's going to fall down, right? It's going to fall down. And how long is it going to take? If I drop something vertically right from the cliff, how long before it hits the ground? Remember, this will hit the ground at the same time if you drop something vertically. How do you do that? How do you do that? Anybody remember? Okay. I'm going to erase this problem altogether up here, and we'll use that as our scrap paper. Okay. How do I find? All right, this is the question, guys. Are you ready?
Yeah.
What is the vertical time to fall a vertical distance from rest? Let me say that again. All right, think. I go like this a lot, don't I?
Yeah.
That's because I have holes in my head, and when I really want to think, I have to put my finger into the hole to maintain a thermal equilibrium with my head, with my brain.
So kind of like a bowling ball?
Yeah, sort of, but I have like several holes around my head where I have to go like this, and that keeps the holes closed because I need to heat up my brain when I really have to think, you know, because I have like a missing bone, and the heat comes out of my brain too fast, so I gotta go like this. See? I have holes all over my head. Yeah? So what would be, are you ready? What is the time to fall a vertical distance from rest. What's the equation? It's on your equation sheet. What is the, listen to me now. Time it takes, see I have two holes right over here, see? You know? Okay, right here, I can feel them, okay? Yeah, ooh, wow, cool, okay? Time it takes to fall a vertical distance from rest. Time it takes to fall a vertical distance equals
You know, times A.
No,
Two
dy
dy
over 5.
over,
Well, 10. I said dy over 5.
excellent, nice recovery, excellent. Over what?
10.
Over tx. dy equals the square root of dy over 5.
I'm telling you, the girl is good. Excellent. That's what I was waiting for. The 5's in the wrong place because it's going to be 2 over 10 or dy over 5. You get it?
Yeah.
Excellent. So give me an answer to that. So root, or if you're from Alabama, it's rut, the rut, 1,000 over 5. The root, 1,000 over 5. 14.1. Let's leave it at 3 significant figures, all right? Or I'll have the significant figure police come in here, okay? Give you a lecture. No significant figure abuse, please. So what's it going to be? 14.1 what? Seconds. Okay, good. Now, it's going 500 meters per second. So how long before it hits the ground? Hey, I can do this. I know what I'm doing. Finally. You ready?
Oh.
So dx equals vxt x. Right? Because ty equals tx. Correct? Yeah! So, what is 500 times 14.1? 750? 7050? 7050. Okay, I like that. 7050. Okay. So dx is going to be equal to 7050. That's called getting the high ground. What's the, divide that by 1600. What is it? 4.4 miles. So that's why you get the high ground. That's really important. What World War II battle, the Germans had the high ground in Italy for the longest time, and it took us forever to defeat them? What battle? Look it up. The Battle of Monte Cassino. Terrible, terrible battle. Anytime you see a veteran of any war, you know what you say to them? Thank you very much. Okay? All right. Now, so that's it. Are we done? So, are we done? Yeah? Should we do another one until the stuff goes off? Yes? Is that good? Okay? Yes? Okay? Now remember, let me remind you, I have what? What do I have?